Hi everyone. So as per schedule, today's topic of discussion is going to be on basic reproduction number. So R-naught. R-naught is called as basic reproduction number. So let's see a little bit about it. So what is basic reproduction number? What do you think is the definition? So basic reproduction number is the expected number of secondary cases produced by a typical infected individual during their entire infectious period in a population consisting of susceptibles only. So let's see that with an example. So this is the population. Let's assume. Okay. All are green, all are very innocent, nobody has any immunity. And now comes our infected individual. Okay, so this infected individual, say he has an infectious period of 14 days. Example. So if he has an infectious period of 14 days, during the 14 days, how many people does he infect? That's what basic reproduction number means. So if you have to put it in writing, how are you going to write? You are going to state basic reproduction number is the number of expected secondary cases produced by a typical infected individual. All wordings are important. A typical infected person when during their entire infectious period were in a population of susceptible individuals. Okay, susceptibles only. They do not have immunity through natural infection or vaccination. Okay, so this is a very idealized scenario. So this does not happen in reality. So what happens in reality is something called as an effective reproduction number. So what is an effective reproduction number? It gives the current scenario. So population's current susceptibility is taken into account while you are calculating the basic reproduction number. So what are the factors it will depend on? It will depend on the immunity in the population. The immunity can be due to the vaccination program or the immunity can be due to a natural infection. So this is a more realistic depiction rather than your usual basic reproduction number. So for calculation of R-naught, what are the factors that are important and how are you going to calculate it? So calculation of R-naught depends on three factors. What are the three factors? Let's see. First is there should be a person who's having infection with an infectious period. So there should be some infectious period, correct? Then during this infectious period, patient should be able to transmit this infection. So there is a transmissibility. Transmissibility. Okay, transmissible proposition. No, transmissible possibility. Yeah. So person is able to transmit the infection. My English is so poor. All right. So if even if this person transmits, somebody should be there to contract that infection. So they should come in contact with this person, right? So contact rate. Correct? Ah? So one person should have an infection, that person should be able to transmit, and another person should come in contact to contract the infection. So all these together will give you the R-naught. So if you want to put it in a, formula format, so you can say R-naught is equal to, so this symbol that I am putting down is the transmissibility. So transmissibility is the probability of infection given a contact between this infectious person and a susceptible individual. Then this is the average rate of contact between susceptible and infected individual. So this is contact rate. Then what is left out? D is the duration of infectious period. So the duration of illness might be different and the duration of infectious period can be different. Some diseases start transmitting even in the incubation period itself, isn't it so? So this is duration of infectious period. All right. So these are the determinants of R-naught. So this is more like a dimensionless number and this is not a rate. So this has a unit of 1 by time or time to the power of -1 will be the unit. Okay, this is not a rate. Remember that. So what are the factors that can affect this R naught? So factors affecting R naught. Same three factors which are important in calculation is going to affect R naught, correct? Huh? So host factors, pathogen factors, environment factors. So let's see, like any other infection, let's calculate like that and see. Factors affecting R naught. What about the host? So host, if the person is, having a good immunity, the period of infectious period might be less. If the person is malnourished, person is having a immunocompromised state, then the duration of infectivity might be different. Then behavior of the infected population. So let's see, hosts immunity, then immunity of the population. Both will play a role, correct? Then behavior of the infected population. Are they going to stay at home? Are they going to come out with protective measures? Or are they going to wander out without having any protective measures? Like in COVID right now, you see some of them are being very careful, but some of them are flippant about the protective measures, right? Then number of susceptible contacts the infected person is going to interact with. So number of contact interaction, let's put it like that. What about the pathogen? So pathogen depends on the virulence, depends on the infectiousness. Correct? Both terms are different. Virulence is how bad is it going to affect the individual. Infectiousness is the transmissibility. And how long is the duration, how long is the pathogen going to be infective? So these two things. What about the environment? So environment, whether the transmission requires the presence of a vector or not, depends on the demographics. Is it a mobile population or is it a population that's going to stay there or is it a population that contains more susceptible individuals like older generation or very young children, right? So these are all the demographics. Then socioeconomic factors are, overcrowding, poor sanitation, those sort of things, and climatic conditions, of course. So these are the things that can affect the basic reproduction number of any disease. So importance from an epidemiological perspective are two. Okay. So one, your you'll be able to என்னன்னு சொல்றது? So you'll be able to calculate the susceptible population that can get infected. So ability of this infection to infect a susceptible population can be determined. So for example, let's put the side topic. Importance of R-naught. So ability to infect. Ability to infect, Naka, what do I mean? Suppose R-naught is less than 1 pa. If one person is affecting less than one individual during their entire infectious period, then it is going to die out on its own. It's not going to become an epidemic. Does not have a epidemic or pandemic potential. Epidemic illana pandemic will not come. Correct? But if the R naught is more, so if R naught is say 2, if one person is infecting 2 during their infectious period, then yes, it has the potential to become a outbreak or an endemic. If the R naught is 5, 6, 8, 10, then epidemic or pandemic potential. So depending upon the number, you can determine whether it will become an outbreak, uh, endemic, epidemic, or a pandemic. Okay. So this is one of the importance. The second one, so you saw the effect it is going to have. So what are you going to do? You're going to put in efforts to stop the spread of infection. Correct. So it R-naught will help you determine the effort needed to curb from getting it to spread like an epidemic or a pandemic. So steps necessary to prevent it from that conversion, it will help you determine how much effort you need to put. So say what proportion of population will need to be vaccinated. So what proportion of population will need to be infected or develop immunity to have a herd effect. So all those things can be calculated by using a R-naught. But there are certain limitations. It's not as straightforward as we are studying in theory. So practical, you do not have, first of all, an idealized scenario, right? So in an ideal scenario, everybody is susceptible, so calculation is easy, but you do not have an idealized scenario, right? So there is no ideal scenario in reality, correct? Then you need to know all three factors. You need to know the transmissibility, you need to know the contact rate, you need to know the infectious period in order to calculate the R-naught. Why am I putting this as a limitation is that if you have a new disease, then it is very difficult. You do not know the infectious period, at least in the initial stages. Even if you find that, you do not know how effectively that person is going to transmit, and you do not know the contact rate. Right. So, for example, in COVID-19, we did not know this in the initial periods, and it is still evolving. Things keep changing with newer strains, newer R-naught keeps developing. Correct. So, all three things need to be understood in order to calculate an R-naught, which may not be possible in case of a newer epidemic. The other thing is, if a person is asymptomatic and still transmitting, then the calculation becomes all the more difficult because you do not know who is actually infected in order to put them into this calculation formula, correct? Huh? So asymptomatic or mildly symptomatic people transmitting infection. Again, you will not be able to calculate. And changing susceptibility of the population. Suppose if a person who's already infected is getting this infection again, the South India, we are having this new COVID variant. It's 441, I think, if I'm not mistaken. So that seems to be, affecting individuals who have already had a COVID infection, and it seems to be more, effective in spreading COVID-19 compared to the earlier strain that we had. So things keep changing. If changing susceptibility of the population cannot determine R-naught, then control measures will be very difficult to put in place. You will not be able to determine what sort of a control measure you need. You will be done with something only to be faced with something else, something new. Correct. And you need to start the process all over again. So changing susceptibility of the population, I've put it as change in susceptibility of the population rather than change in strain because not all the time change in strain might lead to change in susceptibility. I hope I'm making sense. Say, so X disease is causing disease in 20% of the population. The X1 variant might cause same 20% or 15% in the population. So susceptibility has not changed. In fact, it has reduced, right? So strain does not matter. The susceptibility of the population to the strain matters in calculation of your R-naught. So changing susceptibility of the population makes it difficult to put in control measures. So these are all the shortcomings of a R-naught. So why I have taken this class is I just had a feeling. So this might be a probable question in your theory. Maybe not for this. In the upcoming exams, it can be asked, or it can be part of your ASCII where they can give you, transmissibility, duration of infection, and contact rate, and ask you to calculate the basic reproduction number. So if you want to go through the answer with me once again, you can stay with me, or you can say bye bye and go here. So if this question is asked, basic reproduction number, your definition will be number of expected secondary cases produced by a typical infected individual during their entire infectious period in a population of susceptibles only. This is only in an idealized scenario. In a realistic depiction, you need an effective R-naught, where the current susceptibility of the population is taken into account. Calculation is by multiplication of transmissibility, contact rate, and duration of infectious period. The unit is time to the power of -1, and this is not a rate, this is a dimensionless number. Factors affecting R-naught, the host, pathogen, and environment. So in host, what are the things? The immunity of the host and the population, behavior of the infected population as a whole, and number of contact interaction. Pathogen wise, the infectiousness of the pathogen and duration of the infectiousness of the pathogen. Environment wise, whether it requires a vector, the demographic, socioeconomic status, and climatic conditions. Importance of R-naught is twofold. One, you are able to find the ability of the organism to infect a population and the ability of it to become a epidemic or a pandemic, and efforts needed to stop it from becoming an epidemic or pandemic. The limitations are you do not have an idealized scenario in reality. You need to know all three components in order to calculate R-naught. You cannot substitute anything. Asymptomatic or mildly symptomatic people transmitting infection causes a significant difficulty in calculation of R-naught, and changing susceptibility of population again will put a dent in your plans for institution of control measures. So that's it about R-naught of an epidemic or a basic reproduction number. Whichever question is asked, it's one and the same. So hope this was helpful to you. Please subscribe, hit the bell icon so you get notification whenever I post a video. So thank you guys and all the best.